doing it. Okay, then I'm going to do it like this. So yeah, so I'm going to be talking about data and model version control. And so yeah, how the flow of presentation is going to be is just going to provide some introduction on how the concept works and a small like a hands-on demo along down the road. So to make sure everything going to be hopefully clear. So a little bit about myself. I joined UMC Utrecht department CTI specifically as a data scientist halfway in December 2019. And I'm coming from an engineering background, and I did a PhD in applied mathematics, systems and control in Groningen at Groningen University. So if you want to connect with me, there's this data science Slack channel that we have. You could easily find me via my name there. So to start with, yeah, we all have the situation of working with multiple versions of data. And for example, it might be a CSV file, an Excel file. Sometimes you want to change some columns there. You want to change the type of some of those. If you're a data scientist or a data engineer, so probably you want to maybe sometimes introduce new feature. Depending on the type of data that you work with, you might sometimes dump your data as a, for example, image file or JPEG file, for example, or a soundtrack or a video or a text somewhere in your data directories. And if you're a data scientist and sometimes also a data engineer, you're working a lot with the models, statistical models or machine learning models. And sometimes you have to deploy them in production. Sometimes you want to train a model based on some data. And again, the data change, and then you have to train it again. But sometimes, yeah, but indeed, you don't want to lose track of all of these versions. So when we talk about data, the data could be a CSV file, it could be a directory full of files, and a machine learning or statistical model. But the challenge here, it's going to be even more if you're in an sort of a big project that you need to collaborate, and each user might need a different version of the data or the model. So yeah, then here it comes the concept of how we can version all of these data and also get the desired version that we want. So yeah, problems become simple when there is already a solution. So I already start with a solution. So somebody already fixed this problem, and the solution that was proposed was a pointer and a data way. So you would have data, and you would have a pointer that points at the data. So for example, if you're in a storage, if you have a data.csv version 1 in your storage, you have a pointer pointing at this data. And the orange pointer arrows are pointer is on, let's say, and gray arrow, the pointer is off. And so wherever you have a version of your data, you're using an arrow to point at that, and only one arrow, one pointer or arrow can be on at the same time if you have more than one version of that data. So for example, if we go to the middle image, there's a storage, we have a data.csv, there is a version 1 and a version 2. So from the left to right, we have included the new version and also a new pointer. And one of the pointers is off and the other one is on. Now, if we have, for example, 3 versions of this data, and now I'm typically taking one, for example, CSV file as a data, but this could be also your machine learning model or the whole directory as a data. So then you have different version of your data, and only again one pointer is turned on, and that is, for example, pointing at a second version. Yeah. So now what we see with this this pointer and data concept is whenever you have newer version, you can choose if you would like to point at the latest version or if you want to point at the, for example, second version or even older. So decoupling the pointer and data storage. So basically what you would see in this concept is the pointer that's pointing at the data version is decoupled from the data itself. So, and here's the idea of this decoupling and the concept of pointer and data, because then you would have a very light pointer, sometimes of a scale of a byte, and you have a data which might be as heavy as, or for example, of a scale of an order of megabyte to gigabyte or terabyte. So now you would have somewhere that you would store all of your pointers. And let's say this is a pointer store, and you have somewhere that you store your data. And you would hand over these pointers to the user, so they can use these pointers to point at specific version of the data that they are interested in. And of course, the data store could be both in the cloud and on-premise. But the thing is, when you're working with delicate data that are so many about the privacy of the people whose data are in your hand, then you should always be careful about where you are storing these data. So the good, interesting thing is this concept of pointer and data storage. It would allow you to decouple where you store your pointers. For example, that could be in the cloud, because that doesn't have anything about the data itself. It's just like a metadata that's pointing at the right version of the data that you want. And you can keep the data itself still on premise on your, for example, on your local machine, or also in an environment that might be closed and having no access to internet connection. For example, you have a server that you can only SSH via an internal workstation. So the whole idea was decoupling the pointer and storage. So I'm going to do a rather short demo along the road to elaborate on the concept and how this pointer and the data, the decoupling and the storage would work. And please feel free to jump in if there is anything unclear, or if there is a question. So I could elaborate upon it. And so for the point store, what we're going to use GitHub. So that's widely used as an open source Git server, and we're going to use Git as a version control. So the thing is, which is also interesting, the whole idea was, the solution was proposed as a data version control, DVC, but still you would see majority of the uplifting is done by the Git. And down the road, you're going to see this, because basically data version control is nothing than just a simple pointer, which is a meta file that you are version controlling it via GitHub. But this solution, while it's not really doing a data version control, but it indeed solves the problem of version control given the available technologies. So I'm going to continue now with the demo on this. So what you need to do, you need to first install DVC, and there is, for example, if you are using a Windows, you need to use Chocolati. So that's a package manager for Windows. If you're in Mac, you can use Bro. And if you're on Linux, you can use pip install, but you can also use pip install for basically all of them. So what you first need to do, you would make a Git repository to store the pointers remotely. So that's what we're going to do. We're going to store the pointers in the Git repository, and we're going to store the data itself on my workstation or on my machine. So I've made a video of this to simplify this. So what would you do? You would go to a Git repository. You give this a repository name. It should be unique. For example, UMCU DVC tutorial. Then you create this repository, and you will go to your GitHub and you check if it's created already, and you see there it is, and you just clone the link. you come down to your terminal. You navigate to somewhere that you would like to clone this Git repository. It's going to be here, for example, in repos UMCU. You would clone it, and now you would have your remote Git repository attached to your local workstation. Then, okay, okay. Thanks for mentioning. Let me. Then I should not. I'll play it again here. So yeah, it should be moving now. Yeah. Okay. Yeah, the problem is if I do it in this way, I don't see, get that, for example, how do you say that button to tune where you want to stop the video and where you want to continue. So, but it's fine, all right, already. So now, yeah, we have created the repository. We have cloned the link. Now we would come to our terminal. We will navigate to the location that we would like our remote Git to be cloned. So now we would git clone that URL that we already copied. And so basically now we have this UMCU DVC tutorial. We would navigate to that file and we will see what's inside it. And the only thing that we saw there, it was just .git. What we do here is we write DVC in init, so the initialized DVC inside our Git repository. So what we did, we went and made a Git repository, both remotely and locally. We saw inside the Git repository there was only one .git file. What we did, we used DVC, which we already installed it, and we initialized it. So DVC initialization. And then we will see there are a couple of files added into our Git repository. One of them is .dvc file. Another one is .dvc ignore, along the .git that we already had. So what we do, we whatever we have here, we will add it. So we will say git add because we want to keep track of everything that's here. And then we will comment it by just a comment that DVC is initialized. So, and we will push it to our remote repository. So what we did, we basically, what we basically did, it was just very simple. We just cloned the Git repository. We initialized it with DVC. There were a couple of files created by this DVC, which we'll later on down the road will go more into their detail. So the first step that we're going to do after that is, again, we are already in this directory. If you're not, we're going to navigate there. We're going to make a simple data file in our desired extension, for example, xlsx. And we're going to use DVC to make a pointer for this data. So I already told you about the concept of data and pointer. So what we're going to do, we're going to go and make, for example, a very, very simple Excel file. We're going to put some data there. We're going to make the pointer to that Excel file, and we're going to keep track of the pointer. So here into the repository, data repository. So what we did, we went into the data. I already made this. I made a data file. There's a column name, Tom, Jack, Nick, Julie, and each one of them have an age, for example, 40, 20, 72, and 80, blah, blah. So now we come back, we go to the terminal, and we write DVC add data / data.xlsx. You already saw there was a new file getting added here. So let me see if I can, I don't know if I can go back so you could just see the moments that this file just got created. But now you would see another file. This is the pointer. So this is the data file and this is the pointer. And whatever which was it get added, the DVC add did, it was basically making a pointer for the data file. And what we do here, the DVC suggests to track the change with git run this command. So you would write git add data slash data.xlsx. So this is our pointer. So you would add the pointer and okay, maybe I can yeah, I've lost my cursor to exactly point to here, but I'll just play it again. So we already came all the way down here. So we had a data file. Yeah, I'm repeating this again. So I did a DVC add data backslash data.xlsx. So basically, when we did DVC at data.xlsx. This is our main file. So this is the file that we want to make a pointer for. So this command, what it does, it makes the pointer. You just saw a new file got added to the directory. So what DVC suggests you is to track this file by adding it to your Git repository and also include the data.gitignore. So the data git ignore is good because then you could ignore the main data file not to be sent into your remote repository. So what we did, we just copy paste this command here. We continued. And then after we have add this, we're going to commit this. We're going to give this a message. A data pointer is added with git ignore, for example. So yes, this is automatically does everything for us. So later on, I'm going to navigate into the git ignore, and you would see by copy pasting that one liner, it would indeed automatically add the original data file into the git ignore, such that you don't make a mistake and push it into the Git repository. But you could always check that manually to make sure. So now we have pushed the data into the Git. So again, we're gonna go to the data and we're gonna see a new file is created. We can also see it here, that new file. And what we do here, we see basically what's inside that pointer. So I told you about the concept of data and pointer, but here I just use the cat command to see what's inside the data.xlsx DVC. What I see is just MD5, and that's a sort of a algorithm and a function to create a hash. So, and the size of the file and the path. So the path is basically data.xlsx. The size is around 8,736 bytes of the file, but not the pointer, because the pointer itself is around 77 bytes. It's very light, and that's the whole concept. You are, you are assigning a pointer to a file which it might be heavy, but the pointer itself is very light. It's just about 77 bytes, and you would also give it a hash value to keep track of the versions of the pointer. So this is all taken care of by the DVC. So what would you see here is this. And basically now we have made a data file and we have assigned a pointer to that data file and we have sent the pointer to the Git repository. So what would you see? This is your local machine. This is basically your pointer. Your pointer, the difference between your pointer and your data is just the extension of .dvc. So your pointer is now called data.xlsx. That's your data.xlsx, and your pointer is data.xlsx.dvc. And this is the first version. These two are connected. They reside somewhere in your local Git repository. You push the pointer to the GitHub. This means, yeah. When you do this line, this was exactly the question that I was asked. I think it was you, Sander. Yeah. So what does the git ignore do? So when you use the cat command data slash the git ignore, sorry, backslash git ignore, you would see this inside it. So the data.xlsx is git ignored. So this means Git will not push this data to the GitHub and pushes only the pointer. So any questions so far? Then I will continue. So what we already did, we created a data file. It was an of an extension of xlsx. We assigned a pointer to this data file, and we pushed the pointer into the Git repository. There is a pointer version 1 already available in the Git repository after we pushed it. But what we still is left to set up is what we want to do with the data itself. So we have already pushed the pointer. We already took a version control of the pointer. But what about the data itself? For that, we're going to connect the data to a data store. So I already mentioned this could be into the cloud or also on premise. For example, you could attach it to an Amazon S3, all of the blob storages in the cloud providers, for example, Google Cloud Storage, Microsoft Azure blob storage. You could also do a very simple thing and also attach it to your Google Drive. But we already saw our data had an age. So yeah, each person had an age. So it gives us the flavor that there might be some private data there. So then we're not going to do use a remote repository. We're just going to do that locally. So we're going to put all of these data in a directory inside our, for example, computer. So to do that, we already did all the steps. We have done everything, but still we have not configured our data version control. So what we need to do, we still have to configure what is the, how should the DVC connect with the data store. So when we apply the cat command to .dvc.config, so this was one of those internal and hidden files that DVC automatically created for us. And I already told you that down the road, we're going to see what's the merit of that. And inside that, for example, one of those files, .dvc, there is a config file. So here you can really specify how you would like your data version control to interact with the data. Where do you want it to store it? So to set this configuration up, we will make a directory. So I will go to repository UMC Utrecht. That's the same place that basically I have my Git clone. I've cloned my Git repository. Then there I'm going to put a DVC data store. So this is where I'm going to store my data. This is a very important location because we are using a local storage. If you lose this directory, all of your version of the data are going to be lost. So you have to be very careful where you put it and how you're going to treat it. Then we're going to add this directory to our DVC, and we're going to give it a name. So I'm going to say DVC remote add, and the flag D is default. I'm going to give it a local directory. So if you would, and I'm going to attach this directory to it. So if you would wanted to use a remote one, so you could give it another name, say remote remote URL, for example, and attach an S3 or a Google Drive to this. And then when you apply the cat command to the configuration file, you would see that says it gives, actually, it's a kind of mocking your remote repository with a local repository, so which you have called it local remote. So and And here you would see, instead of attaching a URL to this repository, it's basically attaching your directory, yeah, the address of directory. And so what you just need to do, and then you apply the push command. So now we have basically set up also this part of version control. We already figured out what to do with the pointers. Now we also figured out what to do and how to set up our data store. So yeah, we're gonna see also a video of just what I explained it to you. So if we apply the cat command, we indeed see there is nothing inside DVC configuration file. We're going to make a directory that is inside our local workstation. And this address is quite important. This is where we're going to store all of our data. And if we lose this directory, all of the data are going to be lost. So, and we're going to tell DVC configuration that we would like to add a remote repository, but we are faking kind of, because we are not giving it the remote repository URL. We're just attaching a local address in our memory to that. And when we go inside the cat DVC config, we will see that local remote, and this is the URL. And you would also see the local remote as the name. So this is how we are attaching. And now we just use DVC push and one file pushed. So by pushing that DVC pushed, we completed the chain, yeah, because we already made the pointer, we already sent it to the remote GitHub repository, but now we also completed the whole story with first version by also pushing the data to the directory that I defined. So if I would go into the directory that I had, both the UMCU DVC tutorial and the DVC data store, this was what I just created. I would apply the tree command. I would see that I have my data file. So this is the data file. I have the pointer to this data file. And I do also have data storage, you know, like some sort of like a data store in my local machine that stores the data, and this is represented by E4. And there is a connection between this strange number that you see and the hash that you saw in the pointer. So that's basically, yeah, under the hood, how DVC is connecting the pointer to the data. So now let's do a trick and see how does this work. So what I'm going to do, I'm going to delete the data file and see if I can retrieve it from my data store. So I'll go here. Yeah, this is the data.xlsx. So I'm going to remove this. So I'm going to write rmf data.xlsx. So I just removed it. You can't see it here anymore. I still have the pointer though. And I'm also going to remove some of the cache files inside the DVC. And that's important because, okay, that's good to do because, yeah, because if you want DVC to properly work, yeah, DVC is always working with keeping a cache of the latest data that you have had. So I'm going to also to delete that to make sure that I do not have any trace of my data. And I'm going to see if the pointer is really capable of bringing back the data that I have just deleted. So I'm going to do a DVC pull. Yeah, so I deleted the file, I deleted the cache. So now there is no trace of the data. I'm going to do a DVC pull to pull the data from the data store, which is my local repository. And I say, yes, indeed. So the file came back. And And even though, yeah, every trace of the data was absent in my project file, but the important thing was that I had to keep the pointer in my repository. So let's do another step. So what are we going to do now? We're going to change the data file, and we're going to we're going to make a new version of the file, and we're going to make a new pointer to the file, and we're going to carry the same step. Yeah, to just, do another round of version control. Yeah, so we have now a new data. So we go to the data set. We had name, for example, Tom, Jack, Nick, Julie. We had their age. Now we want to add their hobby as well. So after adding their hobbies and attaching each one of these hobbies to based on the column, we would like to yeah, make a new pointer. So the data file is updated. So now the data.xlsx is changed, is not the former one anymore. We apply the DVC add data /data.xlsx. So what does this command do? It basically creates a new pointer for us, and in the same directory, yeah, in the same location. So this is updated, and now it says to track the change with Git, run the git add data.xlsx.dvc. So now this is the pointer. What I just did, I attached a new pointer to the change data, and now I'm gonna version control that pointer with the Git. So I will go here and I'll basically just copy paste it. So I added this new pointer. I'll committed it to the my GitHub repository, and I'll push it. You can also give it a meaningful comment, so you could be able to easily retrieve your file later on. So this is now Git pushed. Basically, I have so far, yeah, I just repeated whatever I did for the first version. I assigned a pointer to the data. I sent a copy of the pointer to the GitHub. And now what I'm going to do, I'm going to send a copy of the data. Basically, I'm going to push the data to our data store, which is, again, it's local. So DVC push and one file pushed. So basically all the steps once again carried out. So if we go and look inside the pointer, it's interesting to see that the pointer to version 1 and pointer to version 2 follow to some extent they're similar, and to some extent they are different. For example, they're both pointer to data.xlsx. Yeah, that's the data file. The size has increased, and this makes sense because we have also included a new column there. So it's about 100, for example, bytes of size increase, and the hash value is actually changed. So, and this is actually what makes each pointer unique. Each time you assign a pointer to your data, you are making a new hash value inside your pointer file, and send that and basically version control the pointer. And that's the point, and it is the pointer that allows you to always pull back the data version that you need. So if you would look at your Git repository, you would also be able to see the diff. So the green ones are the new change in your Git repository, and the red ones are the old ones. So basically, you would see the size is changed, exactly what I just mentioned, and the hash file is changed. So what we did, we had a version 1. We send it into the we send the pointer to the GitHub. Here we see pointer, for example, version 1. This is turned off. So the only one that's working is basically the pointer that you have on your local machine, because based on that pointer, you're always pulling the data from the data store. And I also just, after the version 1 data and the pointer, I created a new data. I attached a new pointer to that data, and I sent that pointer to the GitHub, and with the name of, for example, pointer version 2. Now, for example, if I want to rule back to version 1, what I just need to do is to go to the GitHub and get the pointer, the pointer that points to the data associated to the version 1. So that's the only thing I need to do. So I will bring that version 1 here. And the one that's always in my local repository is the one at the on mode. The ones that are at the GitHub, they're basically not, they're just like a history of the pointers that you have. They're at off mode. Now, if we go back to the initial diagram that I showed, that you would have a pointer for each data, and one of those pointers is on and basically pointing to the data version that you want. So I rule back to the, so what I'm going to do here, I'm going to use git checkout head one data / data.xlsx.dvc. So basically, I'm going to rule back to the older version of the data that I kept keeping track of. And then I'm going to apply DVC checkout. With these two lines, I should be able to retrieve my file. So I will play this again. So in my data, this was the version 2 of my data. I had a name of all the people. I had their age. I had also their hobby. So what I'm going to do now, I'm going to go into the GitHub. Yeah, I'm going to go to my Git repository. I'm going to write exactly this command. So git checkout head one. Make it a little bit larger. So I'm going to git checkout head one data.xlsx.dvc. So whenever you see that .dvc extension, that's your pointer. I rolled back to my previous version of the pointer, and now I will tell DVC to get me the associated data from the data store to this pointer. By just writing DVC checkout, then I'm able to get the data. So I will just open it up and I will see I don't have that column of hobby anymore. So I roll back to the former version. So this was a very simple kind of demo and example on how data version control works. So I would do a recap a little bit here. So basically the components of a data version control is your data file and a pointer. And you are connecting basically your pointer to the data by applying a DVC add. When you do that, then you would push your pointer to the Git repository, and then you would push your data file to a data store. And when you, so you should be always careful that whenever you apply the dvc.init, and that's assigning a pointer to your data, you would, instantly make a history of that and track that in GitHub. Because if you don't do that and you want to roll back to a specific version of your file, then you're not able to do it anymore because you have not tracked that specific version. And what we did, we made a version 1. We sent the pointer to the GitHub. We sent the data to the data store. Then we changed the data. We did the same thing again. And finally, we took, we pulled the specific pointer of the data version that we were interested. For example, it could be one last push back, one older push. And we'll pull the pointer, and by applying the DVC checkout, the DVC automatically goes into the local storage and get the file for us. And basically, this is it. So this is how DVC works. You could also at the same time include some code, to, for example, work with this, because I didn't show you any code. So it was just basically a simple data file, and we use terminal to version control this. But now you could at the same time have some code. It could be in R, in Python, and you would want to also make a pipeline, for example, based on a specific version of your data. You want to have a specific pipeline. There are also more advanced things if you want to version control not only the data but also the pipeline. The DVC can do that, but you could also do that with the GitHub as well, where you are storing your code. If you for example, keep track of your data and code in a suitable manner. So this is it basically. Thanks for your attention. It was I hope it was not a very tedious talk, especially when it's virtual. And let me know if there is any question and things that you would like to discuss about.